the next one that I want to talk about is the idTech one.
Oh yeah, this is a good one.
Tiago Souza. So fast as hell. They always have some great name for all these idTech presentations. And this one's about their usage of ray trace global illumination. And why I think this is important is because you go on the internet and you see a lot of people saying Doom Eternal looked better. Or you say a lot of people like Doom Eternal looked like this. Why couldn't Doom the Dark Ages just use their tech and not use ray tracing? This entire presentation here talks about why that's such a bad idea. The first part of it is basically talking about why switching to RTGI in the first place. And they go over the previous pipeline that existed to do direct and indirect lighting, by the way, for Doom Eternal. And they describe essentially for the Doom Eternal maps, like a large path tracer running in a cloud and a number of PCs. And it already had a pretty hardcore compute time for those smaller Doom Eternal maps, as well as the compute time is not the only issue, but iteration time as a result, because you change something in a level, especially towards the end of development, you're going to have to recompute all that lighting to see what's happening. And so that was already like a big problem in the last project. Then for the Doom, the Dark Ages maps, they have a lot more dynamic objects in it. They have a much larger size, more geometry. It's like 4 to 10 times depending upon the map. And then Tiago very nicely here gave us some great numbers as to what if they were to use Doom Eternal's pipeline in Doom the Dark Ages, what that would look like. So here on the slide is Oliver showing on screen right now because Oliver's a real G. What if Doom the Dark Ages used the exact same older tech bits? Here they describe it would be on disk anywhere, depending upon the average level size, 44 to 110 gigabytes. 110 gigabytes potentially of just just baked lighting on disk. And it's not like full quality lighting, by the way. It's already half size.
That's the key, right? That's just the lighting data, not the game.
The network storage, that's less important for us as the consumers, but for them, that's like an upkeep cost. And it's constantly rebuilding if all the artists are touching levels. And then the turnaround time, the build time for all the levels, at the minimum 27 days. Max 68 days.
Okay.
I don't even know what you do at this point in time, because you would kind of have to be editing levels with incomplete and wrong lighting until the very end of the project when you say, okay, we have time to build, we have actually time to build here. And you could be having the case like with older games where they would ship either accidentally or on purpose levels with incomplete lighting. Like that happened in Mirror's Edge. I'm pretty sure it happens in Quake 2 for a number of levels that didn't.
It was actually Doom 2016 itself on PlayStation 4. There was a broken level in there where the light maps got messed up somehow, and it was broken for months before anybody actually realized, because it was way after the game came out. And it's just a tiny little thing changed and it broke all the light maps.
and they describe like a lot of things, like if an artist pushes a build, what if it didn't finish because of a Windows update or something like that? Like this is like literal stuff that can happen that we don't see as a consumer, but it totally affects their development. So from our perspective as a consumer, they want to switch to ray tracing because one, it's going to produce visually better results, which they talk about in breadth during the thing. But they also like, do we really want to be downloading 110 gigabytes just of lighting data? I don't know. I probably don't want it at this point in time. From their perspective, it makes the game development within a short period of time actually possible. Otherwise, not possible. Game costs much more, comes out later, potentially is worse because they can't iterate it on as much. There's so many issues, so they have to switch to it. And I think that's an amazing thing that Tiago put in the presentation. So grateful for it. Kind of similar to the thing that we also saw in the Ubisoft presentation, but Ubisoft's world is much larger because it's a big open world. So the numbers there were even more insane.
Now, of course, there are arguments that this is necessary because of the type of game they decided to make, right? And some people will say, well, I prefer Doom Eternal, and which I get, actually, and Doom Eternal is incredible. But, artistically, they wanted to make this game with much larger maps, and the technology is what allowed them to do it. They could have made another game like Doom Eternal with the smaller scale, and I guess the old techniques would have still been viable, but essentially ray tracing opened the door to allow them to make the thing that they wanted to make.
I mean, yeah. I mean, so the thing is, they could have made another Doom Eternal, but then they would still be constrained by the tech that they had at the time.
Right.
There's just they could have also made Doom Eternal with RT lighting, and it would have came out much quicker. You know what I mean?
And I feel like as an id Software game, it is nice to see them pushing tech in this way. This is traditionally, from the Carmack days to the Tiago days, it's always been about sort of like taking that leap and trying new technologies. Sometimes it's successful, sometimes it's not. But it's always interesting. And I think this was an important step forward, and one of the fastest and best looking implementations of RTGI we've seen this whole generation. It really is fast as hell, I would argue, just as the title implies.
It's fast and stable. It doesn't seem to be very artifact ridden. That's a lot of the design there. You can read about the design of it. It's also really well done. The second part of the presentation that I just wanted to call out one little thing is that, because we're starting to see more of it in technical presentations, is actually developers talking about console performance across the different things. Right. So there's a slide on here talking about the performance targets, not at a flat resolution for everything, because Series S is still listed there as 900p, and the PS5 Pro and the PC there are running at different resolutions, but we actually get to see the 4K twins. And in this case, 1440p twins of Xbox Series X and PlayStation 5. And they actually have a breakdown of the various steps of the ray tracing pipeline and their individual costs. But like the cost that is actually the linear cost is interesting without async compute, but the async compute cost in the end is actually interesting, because you see a roughly 10% Xbox Series X speed improvement over what the PlayStation 5 was. And that kind of calls back, even Tiago in the footnotes here does call it out as coming from that higher teraflop figure in the Xbox Series X. And I kind of feel like for those next generation techniques, that is when we should start seeing Xbox Series X, assuming parity in development time and resources, pulling ahead, because it has more shading power, and things that cost shading should run faster on a bigger GPU. But it's interesting to see actually someone point this out in a presentation. The last time we saw something similar was the Assassin's Creed presentation, where they talked about cross-platform performance at the exact same resolution, where you actually got a sense like, oh, there are things that are way faster on this platform versus this platform. And I really like seeing that called out. I also like the fact that you can see just how, I mean, for the what they did with it, it's pretty good. But Series S is also just pretty darn slow.
I think something which is slightly curious, Alex, is that the radiance cache and irradiance volumes seem to be twice as fast on PS5 than they are on Series X.
Right. I could only begin to guess as why.
It's funny because the overall cost on PlayStation 5, which is borne out in the actual final game, is actually higher overall.
Right. I think the reasons for that is the radiance cache and irradiance volumes. So the world sampling should be the ray tracing step. That's the stuff that is going to be running through ray tracing accelerators, as well as using generic compute for all the stuff that, like BVH traversal, etc. So all of that. But the radiance cache itself should be a texture lookup and stuff like that, which is the area where we know that the PlayStation 5 has the edge due to its speed, essentially, how fast the individual CUs are running. So I think that's kind of, I would assume that's what you're seeing there. If you look at a step like denoising, which is a pure compute step, you can see that Xbox Series X and PlayStation 5 have pretty different.
There's a huge gap between world sampling and PlayStation on Series X versus PS5, where the Series X is a lot faster.
Mm-hmm. Yeah. So it's like in the end, you have kind of different designs. I'd say like PS5's design is really good, since how long it was. Oh my gosh, cross-gen. Like it's actually perfect for that, right? And then it still has like the room to breathe on top because they did support stuff like ray tracing. But then like Series X design, I think still proves itself like over time, because it is focusing on the future of where GPUs are at least going in terms of compute, in terms of specialized units and stuff like that.